factor the polynomial given a 0. Okay? So, if negative 3 is a 0, what is the factor that goes in? If negative 3 is a 0, what is the factor? What do you mean 3? If negative 3 is a 0, what does a 0 mean? Crosses the x-axis at that point. Did everyone get the worksheet that you were missing? Whichever one you were missing, did everyone get it?
I'll let you get one.
Come get one.
I didn't get both.
Were you not here Friday?
I wasn't here Friday.
Okay, I need everyone with me. If negative 3 is a 0, what is the factor of the polynomial that makes that a 0? X plus 3. Does everyone agree? Okay. Everyone see how I'm getting that? If negative 3 is a 0, then x plus 3 is a factor. So what goes in the box? Negative 3. Now, I wanted to go through that whole process to let you know, because I'll have the question come up, when do I change the sign and when do I not change the sign? You always change the sign. Sometimes they give you the 0, and so the factor is the opposite sign, so it looks like we're not changing the sign, but we are, from the factor, we are always changing the sign. Does that make sense? Yes, no, maybe? What are my coefficients? Oops. Okay. So I'm going to divide that out. I get 1, negative 3. How are we doing on synthetic division? I'm getting to where I'm going a little faster. Are y'all okay with that? If I didn't get 0 here, what would I do? I would know that it was a remainder, but if they told me that this was a 0, then I did something wrong, right? Or it's a bad problem, one of the two, right?
Is that negative?
This one up here is, yes. So if I write this polynomial, I have x cubed plus 3x squared minus 8x minus 24. Now, some of you from pre-AP may be able to factor that, but the rest of us, is this something we've ever factored before? Probably not, but it's telling me to find the other zeros. Factor the polynomial given the 0. What's the piece of information that I haven't used yet? The multiplicity of 2? Would you agree that that means this should divide in again? That there were 2 of those factors in that polynomial? So you know what I'm going to do? I'm going to do it again. So I'm going to put a negative 3 in the box again. But this time I'm going to use this polynomial. Yes? Well, it's the x, so I'm using this again. If it's multiplicity 2, now they could give you 2 different zeros, but if it's a multiplicity 2, then we're dividing the same thing out twice. Did it work for us? So would you agree our polynomial, I divided out x plus 3 2 times, and now I'm left with x squared minus 8. Everyone agree? Is it? Where would the x go? Would it go with the 0? 0x and then minus 8.
Since at the beginning, since it was like, I think it was a equals negative 3, so is that why 1 is, oh wait, no. Never.
because I divided that 0 out twice. This doesn't factor any farther. You agree with that, since 8's not a perfect square? So I would stop here. Okay, any questions about that one? I think it just said factor the polynomial. All right. For the polynomial, a 0 is given, find all others. Make sure you read the question. I will count off if you don't answer the right question. The last question asked me to factor the polynomial, right? What's this one asked me to do? Find the zeros. If I get factored, I will be really close to that, but I'll have to go one extra step. I always get the question, but I did all the right work. Is it important that you can answer the right question? Yes. If 4 is a 0, what is the factor? X minus 4 is the factor. So what will I put in the box? Good. Positive 4 goes in the box. 1, negative 6. Remember to look for placeholders. Do I need any placeholders here? No. Okay, we ready to do the synthetic division? Okay, add down, multiply, add down, multiply, add down, multiply, and add down. Hand it to Mike. That's right. You could try again and it would probably not go in evenly again. I'm going to set this equal to 0. Unfortunately, what do you notice? We want to see if it's factorable. Unfortunately, it's not factorable. Factors of 5 that add to give you 2. Right? So how do I solve this if it's not factorable? Or, and I want to practice this since it's been a while, quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, do you have a calculator program that will do this for you? What is it called? Won't do you any good if you don't know what it's called. Factor poly won't do it, because factor poly only will work with one that factors. Quad 3. 4 minus 20, which is negative 16. What's the square root of negative 16? Plus or minus 4 what? I. Why I? Because it has a negative and a square root. So it's been a while. Good time to review some quadratic formula. So 1 plus or minus 2i are the other two zeros. Now, if it did ask for all the zeros, what else was a 0 from the very beginning? 4. It didn't ask for it, but 4 is also 0. There are 3 zeros there because it was a cubic. If you are including imaginary zeros as well, there are exactly the number of zeros as the degree. So if it's a degree 3, there are 3 zeros. I'm probably only going to do one of these. Let's do the second one because it's written a little strange. So let's do the second one. I want to know if the divisor is a factor of the dividend. How will I find that out? If there's a remainder or not. If there's not a remainder, it's not a factor. If there is a remainder, it's not a factor. Did I say that right? If there's not a remainder, it is a factor. If there is a remainder, it's not a factor. But they tried to trick me on this problem. What's wrong with it as it sits? It is all kinds of messed up, right? N to the 4th, 0n cubed, minus 4n squared, minus 9n minus 24. Notice I added my own piece in there. Why do I need that part? Do what? Is this the notes from Wednesday? No, this is still from Friday, but they kind of overlap. There's a lot of similarities between what we're learning today and what we're learning later today. So if I want to use synthetic division, what goes where? Negative 2 goes in the box. You will even notice, Hunter, that those 2 worksheets were all part of the same chapter. And the next thing is still part of the same chapter. We just couldn't quite teach it all in one day, so we just split the chapter into several parts. Add down. Am I going too fast on this part? If you forgot the 0, has anyone done that on a homework problem yet? Forgotten the 0? What do you notice that's kind of strange when you forget the 0? When you go to write the polynomial at the end, what do you notice when you forget the 0? It doesn't have enough terms, right? Because you know you drop, like this would be n cubed, this would be n squared, this would be n, this would be the constant. If you forget to put the placeholder in, you will feel like something's wrong. I hope it throws up a red flag because you're like, there's no constant. Don't just not write a constant down. You probably messed up in your synthetic division. Does that make sense? Do I need to do any rewriting or anything to answer this question? This particular question? What was the question? Always keep that in mind. Let's go back up and look. So, is the divisor a factor of the dividend? Do I need to do any more work to show that? No. If it asked for the zeros, I would still need to do some more work, but it didn't. So all I do is stop here and go, no. And if you wanted to explain, you could say the remainder is not 0. That's why. It would be a factor if the remainder were 0. Any questions about that? Yes. Not necessarily, it depends. What? All of what? What's the question asked? Here's what you know, Michaela. If it says a 0 is given, then it better be 0 because that means this is a fact. If 4 is a 0, isn't x minus 4 a factor? So you know it is a factor. That's the only time you know it's going to be 0, if you know you have a factor. Any questions about those? Okay. Both of these are due on Wednesday. Hint on number 5. Divide by x minus 4 in the factor. I don't know why you need that hint. You probably could do it without that hint. I don't even know which number 5 that's a hint for. Oh, that's this number 5. It's saying hint, do the x minus 4 first, because the 2x minus 1, you'd have to use long division. So it's on the 6.3b. Okay, so now we're going to start the, this is where we were supposed to start today, but we just had Friday was so short, we had to pick up a little, which is okay. So I want to give an example of some numbers, and really the main thing I'm trying to find is what a rational number is, but does anyone remember what a natural number is? What is a natural number? Good. Natural numbers are the ones that they're called natural numbers because they come naturally. Like my 3-year-old knows his natural numbers. I'll check it later, stay after class. It does not. So those are called natural numbers. Okay. See. Whole numbers include 0. So same as natural numbers. Integers are positive and negative whole numbers. So 1, 2, 3, 4, 5, but also negative 1, 2, 3, 4, 5. Those are integers. Anyone remember what a rational number is?
Is that like when the decimal keeps going?
Okay, a repeating decimal is rational. I would agree. I want to point you to the root word of the word rational. See that ratio in there? What's a ratio? 2/3, a fraction. So rational numbers are numbers that can be written as a fraction. They do include all whole numbers, because can't a whole number be a fraction if you really want it to be? 4/1. But they also include things like 2/3, which is why repeating decimals are rational, because 0.3 repeating is a third. Irrational numbers are ones that can't be put into a fraction, and those are strange. These are like pi, square root of 2, square root of 3. Is the square root of 4 irrational? No, why not? Because it's 2, so it's rational. Real numbers are all of those things. Complex numbers are things with eyes. So just a quick review of some number systems. Okay, now on the last slide and on the last homework, they gave us a 0, and then we were asked to find the other zeros, right? Well, I have a cubic, and they don't give me a 0. So I want you to get your calculator out and go to your y equals screen. And graph this function. Where does it look like it touches or crosses the x-axis? think I heard something, I just didn't hear it. What was it? Where does it look like it touches or crosses the x-axis? Looks like -3 and +3. I want to make sure that truly is the case. You can either just type it in your table. -3 is not correct. Does everyone see that? So it's probably like 2.9 or something like that, but it's not quite at -3. Does everyone see how I know that? However, at 3, does it touch the... In fact, it just dips down and touches. Do we agree with that? So it probably even has a multiplicity of 2, I would think. But we're just going to go with that once. We'll talk about multiplicity later. So I know that 3 is a 0. I found that by looking at the calculator. So it says use the calculator to find one 0, and then synthetic division to find the others. Would you agree that from the calculator, the one that's close to -3, the best I can do is a decimal from the calculator? So this is going to allow me to find that exactly. So I'm going to put 3 in a box. It wasn't a 0. It looks like it might be, and I went to my table and checked. See? And it wasn't. Was that your question, or is it why am I not changing the sign? Is that actual question? Okay, if 3 is a 0, what's the factor that I'm dividing out? What am I actually dividing by if 3 is a 0? Sort of x minus 3. And so then I do change the sign. Good question. So if 3 is a 0, remember x minus 3 is the factor, and in synthetic division, I change the sign from the factor. Sorry, I answered the wrong question. Uh-oh. Oh, you're right. Good call. Why did I say uh-oh? Yeah, if that had been what I had put down, then it wouldn't be a factor, and that means I picked a bad 0, which would be bad. So my function looks like that. Can I find all the zeros of that now? 3 is obviously 1. I found that one from the calculator. What about this? How do I find the zeros of x squared minus 8? Solve it, equal to 0. X squared minus 8 equals 0. Square root both sides. Anytime you take a square root, you get a plus or minus. What is the square root of 8? Someone with a calculator tell me that. 2.8. So do you see why -3 looked like it was a 0? But I want to show you this picture again. How many of you thought that over there on the right, that only crossed the x-axis one time? How many of you thought that, or touched it one time? It looked like it just bounced off and touched at -3 or at +3. That's what I thought from first glance. It looked like 3 had a multiplicity of 2, didn't it? But it turns out, if you zoom in on that point, you see how it barely crosses? How many of you would have missed that, even using the calculator? Me too, right? Because to the naked eye, it looked like that just bounced off and touched. So this was a really good problem to show you calculators are great, but they aren't perfect. Well, they are, but we might not see them as perfect. We might have missed that. So the zeros here are 3 and positive or negative square root of 8. If you are matching multiple choice, put that up. If you are matching multiple choice, this would be 2 square root of 2. Does everyone know how I got the 2 square root of 2? The factor tree on the 8. Just quick reminder. Lots of review today. Lots of good review. 2 and 4, 2 and 2. And I would pull one of those sets of 2's out, and there would be one left in the radical. Okay. Which brings us to the rational root theorem. The rational root theorem is something that is slightly outdated because of calculators, but college algebra finals are still going to ask it, so we still need to know it. You could always do what we just did. Did you notice how I went and found a 0 on the calculator? And it's a great way to find a 0. Before, calculators did quite as much as they do now, and just to let you know, because I know sometimes we forget how amazing technology is, in the 90s, calculators didn't do what they do now. 90s was not that long ago. That was when I was in junior high, right? So we're talking not very long ago. And calculators have gone from doing very little to tying your shoes for you, practically. And so we still haven't quite caught up, probably, in our curriculum. But college algebra curriculum will still ask you questions about the rational root theorem. So you have to know it because you have to pass the final. The rational root theorem gives you a way to get that first 0. Remember when I went and found it on the calculator, the 3? I went and looked for it. The rational root theorem gives you a way to find it if you didn't have a graph that you could go look at. So, the rational root theorem gives a list of possible rational roots. It doesn't actually give the rational roots, it gives a list of possible rational roots. If f of x is this thing here, and it has integer coefficients, so integer coefficients are whole numbers, and p divided by q is a rational 0. So if there is a rational 0, then p has to be a factor of the constant and q has to be a factor of the leading coefficient. Now I want to show you why. Say I have a function in factored form. I'm just making one up. So would you agree 7 is a 0 and 2/3 is a 0? It takes some work to get the 2/3. You'd have to add the 2 and divide by 3. Everyone agree with that? 7 and 2/3 are the zeros? If I looked at the leading coefficient of this function, it would be 3x squared, and the constant would be 14. So I got 7, and I got 2/3. If those are rational zeros, then the tops of those are factors of the constant. Would you agree that 7 and 2 are both factors of 14? And the denominators are factors of the leading coefficient. Would you agree 1 and 3 are both factors of 3? Now, there is a much longer list, though, so we're not going to pick those out. We're not going to pick out the answers, just we're going to pick out the possibilities. And that's what the rational root theorem does. To you at this point, it's going to feel a little silly because you have a calculator, but we have to learn it. But it's also a nice glimpse into mathematics 15, 20 years ago, and to realize how good you got it. Because they didn't have that graphing screen that they could go find that 0 on. So it's nice to know. So I want to list all of the possible rational zeros. And to do that, I need to know P and Q. pick out my P's and pick out my Q's. P is all of the factors of the constant, and Q is all of the factors of the leading coefficient. So in your notes, write that. Factors of constant and factors of the leading coefficient. So what are the factors of the constant? What is the constant? -2. So what are all the things that could multiply to give you -2? Okay, -1 and 2. Would you agree it wouldn't matter which one was negative or which one was positive? So positive for -1, positive for -2. What are the factors of the leading coefficient? Okay, 5 and 3. One and 15. And would you agree theoretically those could all be positive or negative? Because a positive times a positive is a positive and a negative times a negative is a positive. So that is an exhaustive list of all the P's and Q's. The zeros are all the things that would be P divided by Q. This will take you a minute to write it down. A lot of times on the college algebra final, when they ask this, they will be looking for the whole list. So you do have to know how to do this, because you may have to list the whole. Now it's multiple choice, so you'll just have to pick it out from a multiple choice question. So I'm going to do P over Q, 1 over 1. What is 1 divided by 1? 1. Then I'm going to do 1 divided by 3. And then 1 divided by 5. And then 1 divided by 15. Could this list get very, very long? Yes. And then, so that's 1 divided by each piece. Good. Do what? Did someone ask a question? No. 2, 2/3, 2/5, and 2/15. I want to point out again what this list is. This is all of the possible rational roots. Is there any way that those could all be roots of a cubic? In fact, how many roots at most does a cubic have? 3, at most 3 rational roots. It could have some imaginaries and things like that, but it has at most 3 rational roots. So obviously these are not all rational roots. They are just the possibilities. It says now check and see which ones are actually roots of this equation. Now, another slight glimpse into history. When I was in high school, you know how I had to check these? I had to do synthetic division on all of those. See which ones came out with a 0 remainder. Every single one of them. That's how I had to do it. Am I that old? Don't answer that. I'm not. Not that old. That wasn't that long ago, right? That's how I had to do it because we didn't have TI-84s readily available in class. They existed when I was in high school, but they weren't in our hands. Okay? So to do this, I had to do that completely by hand. You do not. How could I quickly check all of those to see if they're zeros? Use my calculator in the table. So everyone get your calculator out. I'm going to show you really quickly how you can check those, and it won't take you too terribly long. If you start to whine and think it's taking you long, I can remind you how I had to do it, and then you can go, okay, this isn't really that bad. Alright, so go back up to the top, that thing, the equation at the top, put that in your y equals 15x cubed plus 14x squared minus 3x minus 2. Make sure your table is set up where you can type. If it's not, remember you go to your table setup and put your independent variable on ask. Then go to your table and start typing those numbers in. Type in 1/3 and -1/3. Are either one of those zeros? -1/3, how do you know? Because there's a 0 on the y, right? So that's a 0. So I'm going to mark that one down, -1/3. Okay, so go through the whole list. Start typing them in. 1 and -1. 1/5 and -1/5. What about 1 and -1? Either one of those zeros? -1 is. Okay. Sorry. -1. 1/5.
If it's giving you the y one in fractions, how do you fix that?
The go to mode and put your, so you'll see an option like exact, or put it on auto. Is it on exact right now?
Yeah.
Put it on auto. Okay, you go through the list. Someone tell me when you find another one. And I would say if we find one more, we quit looking. Why would I quit looking if I find one more? Why can there only be 3? James, get up. Why can there only be 3? It's a degree 3, right? 2/5 is the third one. Is that what everyone's getting? No. Come on, computer. 2/5. It was positive 2/5. Okay, any questions about that? Would there be any need, if I wanted all zeros, even imaginary ones, would there be any need to do any more work after I found these 3? Why not? Why could I be completely confident in stopping here? There can be at most 3 answers, right? Because it's a cubic. So I found all 3, I'm done. Okay. List the possible rational roots and determine which ones are actually rational roots. So same question, 2 and 1. List the possible and then determine which ones are actually roots. We're going to do this last example. I am going to give you your homework on this really quick. These are the same. We've pretty much done them all. Wednesday, I'll finish whatever examples we don't finish today. This is due on Thursday. Again, I would highly recommend that you do this homework as tomorrow night's homework, since you don't have school at all tomorrow. Because on Wednesday, you will get your review for your test. So you could kind of swing your homework load toward the front of the week instead of toward Friday. Because that review will probably be due on Monday. So, I don't know about you, but I don't like weekend homework. So. The test will be next week. Yeah, it won't be this week. We will do a pre-test and all of that fun stuff before the test. We'll review for a couple days, pre-test. Hey, I've got like 7 minutes left. It's not anywhere near time to pack up. Get that stuff right back out. I just wanted to make sure we got that homework in. Okay, so let's do another example. You're welcome. So, what's due and when that you have? Everyone listen. 6.3a and 6.3b are both due on Wednesday. The bookwork you just got is due on Thursday. On Wednesday, I will give you your review assignment. If any of you want that early, I have it printed. I think it would overwhelm you as a whole, so I'm not passing it out.
Attention, please.
But if you want it early, I have it.
To report to room 83, Bailey Carter, Joanna Busman, Dan Thiesennover, Seth Oliver, Summer Bataki, Kayla Jones, Samuel Haste, Marley Glasgow, Curtis McFarland, Emily McMillan, Angela Davidson, and Desiree Finney, and Andres Mahita to room A3. Thank you.
Okay. Systematic. I wanted to do a big number one to teach you how to be systematic. Get your calculator out. To do the factors of 72, start with 72, divide by 2. 72 divided by 3, right? You know what I mean? See which one's going evenly. 72 divided by 4. All of these numbers are factors. 2 and 36, 3 and 24, 4 and 18. Is 5 a factor? No. 6 and 12. 13 doesn't work. 14 doesn't work. 15 doesn't work. 16 doesn't work. 17 doesn't work. And then when I get to 18, I'm going to stop checking because I know 18 works and 24 works. That goes back up the list. So I've got 12. What was the next one that worked? 18. 24, 36, and 72. Luckily, since P was so bad, what's Q? Just plus or minus 1. So when I do divide everything by that positive or negative 1, what do I get? What will P over Q be? What will that list be? It's the same list as the P. Everyone agree with that? Okay. How do I know which ones work? Table. Do that for me. Get your calculator out. I want everyone to try it. Start checking. How many will it take before I can say I quit? How many will I have to find before I can say I found them all? 4. Now, if you don't find 4, does that mean you messed up? Not necessarily, because we could have an imaginary root. We could have an irrational root. Remember, these are just the rational ones. So it is okay if you don't find all 4. But if you do find 4, you can stop because there can't be more than 4. So do that for me. If one of the... So my hint on that problem was to do the x minus 4 first. And then it's a quadratic that you can factor. So my hint is to not try to divide that up. And if you have to, then you have to use long division.
You can only just
You could trick it and use synthetic, but to me it's harder than just using it. Okay, what Has anyone found one yet? Negative 1?
How do you do it? Do you keep 5 and 5?
No, you just do 1, negative 1, 2, negative. I mean, you do 1 divided by 1, but that's just 1. 2 divided by 1 is just 2. So you'll check positive and negative.
All the numbers is positive and negative.
So I got negative 1. Anyone found another one? Someone start at the end of the list for me. So I got a lot of people who are at the beginning of the list. Someone go to the end of the list and start. And those of you who are packed up, remember, if I keep seeing y'all pack up early, I may start holding you later. Quit stealing my time. Is that the only one? And you check positive and negative? It's positive. Okay, so we only found 1. Is that bad? It's possible. So this is how you do your homework. Okay? If you come to some of the book page that you can't do, we'll do more examples on that book page on Wednesday.